In this episode, we will be unpacking and assembling the printed circuit board that we sent out for fabrication at the beginning of February. We will build two LearningTasmota devices, one with the Maxim DS18B20 sensor and the other with the DHT22 temperature and humidity sensor. Let's get started. Hello all, it's been a while since my last episode of marktroyer.tech. I've been waiting for some parts to arrive from China to build the new version of the LearningTasmotaPCB. The good news is that everything has arrived and we're ready to proceed. In today's episode, we will build two LearningTasmota devices. We will begin by unbagging and inspecting some of the packages that we just received from China. Following this, we will do some quick continuity checks of the new printed circuit boards to make sure that they turn out as expected. We will then assemble and solder the two boards, and finally we will test them out. Let's get set up on the bench. Over the past week or two, we have received two packages. We actually got the PCBs rather quickly, but we were waiting for some other hardware for our low-cost hobby box. That's part of the reason that we were delayed. So we've got two packages. The first package, I already opened this. Push this to the side. This is the actual PCBs that we got from jclpcb. Gave us a nice puzzle to put together. Maybe I'll take a look at that later. And then we got the actual PCBs. Put all this stuff to the side. And I'm just gonna open this up. And so we have 10 nice PCBs. Let's just take one of these out and we'll put these to the side. And again, just to give you a comparison of, this is the original Tasmota PCB and this is the new one. And I happen to have a hobby box here. And there's both the top and the bottom. I'll put the top to the side here just to do a quick spot check. That seems like it's perfect. So the idea is that this will be an enclosure. I'm not sure how appropriate and needed this really is for this project, but I've been wanting to come up with a design and I thought, well, I might as well design this on this board with the sizing just the same. The idea being that you could put batteries and other things inside of here. And I have some other projects which I'll talk about at the end of this video on that. So anyway, that all seems to be great. So that is very good news. Now the other thing that I purchased was some hardware, and this took a little bit longer to arrive. Let's put this to the side. And what you see here are spacers. Well, first off, we've got two different types measurements of spacers, and then we have metal screws which will screw into the spacers. If you look at the hobby box, let me get that back out here. One of the things that you will notice is that these 2.5 millimeter screws are, unfortunately, they screw in at the bottom. I was actually hoping to find a hobby box where this would come up either flush or near flush, so that you would have the option to either completely cover the box or just have it inset slightly. And I decided on this project just to cover the box completely. With that, however, I needed two different sizes of spacers, and so the idea is that I have both a 13 and a 15 millimeter spacer. The 15 millimeter will have it such that the screw holes are just flush with the top, and that's what I'll actually use for this and plug that inside. So good news is that we have everything that we need to get this project started. So one of the first things I'm going to do is do a couple of spot checks with the new LearningTasmota board, and I'm going to do this in two basic steps. First, I'm going to verify that there are no shorts between 3.3 volts and ground. That's to prevent anything from burning or blowing up. burning out mainly. The second thing is I will go through and check each of the GPIO pins to make sure that they land where I think they're supposed to land, and then we'll go ahead and put everything together. So let's start off with the most obvious test. If we connect 3 and again, we have continuity when we touch the two. If we touch 3.3 volts and ground, we get no sound. That's a good sign. Let's now just do a spot check of some of the GPIO ports for some of the different I/O devices that we have, just to make sure that we have continuity, and then we'll go ahead and put everything together. So we will start with the LEDs. So again, the nice thing about this board is that we marked it with both the GPIOs and the D markings. So in this particular case, D8, that should actually connect up before the resistor, which will control the amount of flow going to the LED for the color. So that checks out one, great. So, and then D7, we'll check that, that's good. D6, that connects up. Happy camper so far. And D4, brilliant. Okay, and now let's look at D2 for the buzzer, and D2 is right there. Okay, that's brilliant news. And we will now look at the analog pin to make sure that, there we go, for the LDR, that checks out. And then we'll look at the data pin, and this goes to D4. So we'll touch D4, that's brilliant, and that checks out. And then we have finally the momentary push buttons, and these are on D1 and D3. And so we'll go to D1, which is this one. Yep, that's brilliant. And then we'll go to D3. That's this one. And everything checks out. So I'm pretty confident that everything should work. We'll see. On to the next step. So when we assemble this, we're going to assemble this starting with the lowest profile parts first. So that would be all of the resistors. And then we'll do the LDRs. And then I'll probably do the LEDs followed by the momentary push buttons. And then from there, we'll do the DS18B20, probably the headers, and then the buzzers, and then finally we'll mount the actual DHT22 sensor, and then we'll pop this on each one of them. So let's go ahead and get started. I'm actually going to fast forward through most of the assembly process so you can see it actually being done, but we're going to make this go a little bit quicker. Those look done. So at this point, let's go ahead and turn the soldering gun off. And let's move everything away. Okay, and I'll go ahead and hook these up. Okay, we're back now. I've taken the WeMOS D1 Mini and I have actually placed it on both boards. I started off by putting it on the board that has the Maxim DS18B20, and that all worked fine. And now I've actually got it on the other board that has the DHT22. Now, a couple of things that I didn't anticipate. Maybe they're not so much I didn't anticipate them, but clarifications that need to be made. Everything seems to be working, so if I cover my hand over the device, you'll see the luminance changes immediately. And then I'm just going to breathe on on the DHT, and you'll see that drop down. There we go. And you'll see the humidity rise up. And so that all seems to be working. What I think is important to understand is that this is actually not called a DHT22, at least from a Tasmota perspective. There's the DHT11 and the DHT22. The DHT11 is specifically stated in the configuration in Tasmota, but it's not for the DHT22. It's actually called the microprocessor or sensor chip is called the AM2301, and that's what you need to select in order to see the temperature and humidity. And dew point evidently comes out here as well, which I didn't know that that was actually part of the DHT22, but evidently it is. Just to clarify things, however, if we go into configuration and we go to, normally we would configure the module. In this case, we actually have selected the LearningTasmotaPCB type. So I'm going to go back to configuration and I'm going to configure that because that's actually a template. And in this case, you'll see here that there are actually several selections that you can make. So there's the DHT11, there's the DS18X20, that's for the B or the S20, both of them work. And then you'll see the DHT11, but actually we need to select the AM2301 to make this work. So with that, everything seems to function as we expected it would. So that's all great news. Now it's time to wrap up. What did we do today? Well, we unbagged and inspected the PCBs that were fabricated in China. Following this, we did some quick continuity checks of the new printed circuit boards to make sure that they turned out as we expected, which they did. We then assembled and soldered the two boards, and finally we tested them out and everything worked as expected. Strictly speaking, this will be the 8th and final episode in the Learning Tasmota series. It's been a great journey. We started with some basic configuration of the Tasmota firmware on finished consumer IoT devices based on the ESP8266. We then looked at more complex parts of Tasmota, including advanced configuration options and rules. We integrated Tasmota with a public MQTT broker. We then built an instance of Node-RED on the Heroku platform as a service. With this instance, we created a custom web panel to control and monitor our LearningTasmotaPCB without writing any code. In the last few episodes, we then modified the LearningTasmotaPCB and had a new board spun and assembled. I've really enjoyed creating these last 8 episodes, and I hope that you enjoyed watching them as well. As a next step, I have some additional projects in mind for the future series that include the following. First, I would like to build a low-power, battery-operated PCB that takes temperature and humidity readings. This will likely be based on the LoRa protocol and not Wi-Fi in order to improve battery life. Second, spring is in the air and I would like to build a bird's nest monitoring device based on the ESP32 camera. And finally, I'd like to create a new version of the ice spindle fermentation gravity PCB that works with LoRa and the Things network. If you have any other interesting projects that you would like for me to investigate, please comment below. Thank you again for joining me in today's video. If you found this video useful or interesting, please click on the like button. Please also consider subscribing to this channel to get a front row seat whenever I release new videos. This is Mark at marktroyer.tech signing off.